Let us understand basics of node analysis. Assume five branches which are meeting at a point. Current I1 is incoming current, I2 is outgoing current, I3 incoming current, I4 outgoing current, I5 incoming current. So the Kirchhoff current law states that summation of all the algebraic currents meeting at a node or junction is equals to 0. So let us write down the equation. For incoming current we will write down plus sign, for outgoing current we will write down minus sign. So the equation becomes plus I1 minus I2 plus I3 minus I4 plus I5 is equal to 0. So this indicates that the algebraic summation of all the currents meeting at a particular node or junction is equal to 0. So what I will do, I will rearrange the equation in mathematical form. I can write down I1 plus I3 plus I5 is equal to I2 plus I4. What we can see over here, these are all incoming currents and these are all outgoing currents. So we can modify the statement that it at a particular node or a junction, summation of all the incoming currents is equals to summation of all the outgoing currents. So this is a basic fundamental to write down the equation for node analysis. Now let us see what do you mean by node and how to identify the nodes available in a circuit. So for that we will take one reference circuit. In this circuit, wherever three or more than three components are coming together, you declare that point as a node. See here, this is one node and this will be declared as reference node. Reference node, the voltage at this particular point will be 0 volt. Now, how I have understood that it is a reference node, you can see how many points are coming over here. First component, second component, and third component. And that is the reason I say this is reference node. Let us find out the another point where the node is available. See here also 1, 2, 3 components are coming at this particular point. So this will be also declared as node and we will give some name to this particular node. Let us say this node is VA. One thing is clear, our reference node is held at 0 volt and there is another node which is termed as VA, and now our job is to write down the equation at VA. Let us see how to write down the equation. We will assume that all the currents are outgoing from node A. Let us assume first outgoing current I1, second outgoing current I2, and third outgoing current I3. My equation will be I1 plus I2 plus I3 equals to 0. Now let us take these currents one by one. So I1 is the current which starts at VA and it ends at 0 volt. Okay, and in between there is a voltage source which comes in the path, and there is a resistor which is coming in the path. So let us deal with this component one by one. First of all, what are the points? The current starts at VA and it ends at 0. So the I1 ka equation, how to develop the equation? I1 will become VA minus 0. The another voltage that is coming in the path is 20 volt, and we can see our assumed direction of current is reverse that of the current direction of 20 volt. So we can write down minus 20 divided by the resistor that is available in the path, which is the resistor 10 ohms. So this will become a denominator. So I1 can be represented I1 equals to VA minus 20 upon 10. Let us write down I2 now. We know that I2 starts at VA, ends at 0 and divided by 5. So VA minus 0 upon 5, which is VA upon 5, and I3 is equal to I3 starts at VA, ends at 0 and divide by 7 plus 3. VA minus 0 upon 7 plus 3. So now you have represented values of I1, I2 and I3. These I1, I2 and I3 equations can be placed over here, and by solving this simultaneously you will get value of VA. Once you got the value of VA, the problem is solved. So this was a problem based on a single node equation. Let us see what happens when two nodes comes into picture. So here is a circuit where reference node can be given at this particular point. The voltage at this node can be given by 0 volt. Where is the another node? At this particular point. So we will call voltage over here as VA, and other one node over here. So we will call this as VB. Writing down the voltages. This is VA, this is VB. We will write down equation at node 1. So we will assume three currents, I1, I2, I3. When we write down equation at node A, we will assume all the currents outgoing at node A, and when we write down equation at node B, we will assume all three currents outgoing from node B, I4, I5 and I6. You need to be very specific about this. When you write down equation at node A, all the currents will be assumed outgoing from node A. When you write down equation at node B, you will assume all the currents outgoing from node B. Let us write down equation at node A. So at node A, first current starting at this point, so VA, ending at this point, so minus 0. This battery opposes our direction of current, so minus 20 divided by 10. So the equation is VA minus 0 minus 20 divided by 10. Next current at node A, starting at point A, ending at point 0 and divided by 5 ohm component. VA minus 0 upon 5. plus third current at node A, starting at node A, ending at node B, divided by 7 ohm component. So VA minus VB upon 7 is equal to 0. Similar exercise we will do at node B. Now when you stand at node B, you assume all the currents outgoing. So first current VA minus VB upon 7. VA minus VB upon 7 plus second current starting at VB, ending at 0 and opposed by 3 ohm. So VB minus 0 upon 3. Third starting at VB, ending at 0. So VB minus 0. And now see carefully, this voltage source is in favor of our direction of current. So this will become plus 4 divided by 2 ohms. So the equation is VB minus 0 plus 4 upon 2 equals to 0. This becomes your first equation. This becomes your second equation. So now if you solve these equations simultaneously, you will get values of VA and VB. The final outcome of the problem will be values of VA and VB, and from these values you can decide which current is to be calculated and you can find the value of current.